Hi, my name is Ken, and this is Let's Code a Mud in C++ 11, Part 14. In the last part, we talked about text. We talked about Unicode, ANSI, and Telnet, and the different ways that control protocols kind of insert themselves into text, and how to read them. And what we did with that was we made our tokenizer a little better. We made it so it's able to filter out the telnet command sequences from words. So now at this point, our tokenizer should be returning words in their fully normalized form. And what does that mean? That means that those words are in the one form that is exactly equal to the way that we need to look them up. So when, for example, we have our grammar system that we're going to talk about in this part, we can get a verb and we can say, get the grammar that corresponds to this exact verb, and it's going to be all lowercase. It's not going to have any unprintable stuff around it, and so it'll be able to look that up. It'll be able to find it based on that string. So in this part, we're going to start our grammar system. So what do I mean by that? What's our grammar system? What's a grammar system? Well, let's look at our interface. Let's remember what our interface is doing here. So right now it's just printing our string right back to us, right? And that's no fun. That's we want to be able to, if I say hello, I want the interface to say hi back. If I say quit, I want it to disconnect me. So that kind of thing. So what I want is some sort of object that I can say parse. I can say read the words from the tokenizer, and based on that, do some sort of action that involves writing back to the user. So let's get an O stream for the grammar system to write back to. And then when you're done, we'll come back here and we'll print out another prompt. But so basically handle that command. Handle the words in the line. Write back to the user, and then return when you're done. Really easy, right? So let's look at how we're going to have to do that. So if I go to the mud interface here, I'm going to have an object I'm going to call grammar in a namespace. I should do an include for that. Okay. And let's create that directory. And let's start writing that file. Okay, so do our boilerplate. We've gotten really good at it by now. Typing namespace a lot. This is where having an IDE is a whole lot less painful. Okay, and this is going to be class grammar. And the one thing we already decided on that it's going to do is it's going to parse a tokenizer, and it's going to write back to an O stream. That's where the response will go. And this is also going to be a const method. So what that means is it's not actually going to change the rules of grammar, right? We're just going to apply the rules of grammar. We're going to read the rules of grammar and do something, parse the user's input. So that'll be const. Okay. Now, where are our rules of grammar? Well, we're going to want to have a way to look up the grammar based on the verb. And the way I'm going to assume commands are laid out right now, I'm just going to assume the first word is the command. So, say hi, or quit, or kick the orc. That first word is going to be our verb, our action. And we'll operate off of that. So I'm going to get that first word, and I'm going to want to look up what the corresponding action is. So the right data structure for that would be a map. So we'll have our verbs as the index in the map, the key value. So if I look up hello, I want to get some action that says hello back. Or if I look up kick, I want to get, some combat action. Okay. So that's going to be, we'll call that a grammar action for now. And we'll call this the grammar actions. All right. And I'm also going to need to construct this. I'm going to want to put some things in the grammar actions. So let's declare a constructor. All right. Let's write the implementation for this. So using namespace mud grammar. We said we're going to have a constructor, and we're going to have a parse method that takes a dictionary and returns an OStream response. Okay. That writes to that OStream. Let's also not forget to have good includes. So we should include OStream. We should include dictionary tokenizer. Actually, we can just get away with forward declaring dictionary tokenizer here. So let's see, namespace, dictionary, class, tokenizer. Okay, forward declare that because I just have a reference. But grammar action I don't have a reference to. That's actually a thing. So we need the full header for that. Okay. And then in here, because we're going to actually use the tokenizer, we want to get that include dictionary tokenizer.hpp. Okay. So what are we going to do with the tokenizer? Well, we want to get the verb. We want to get the first word in the sentence. So we'll do getString. We're getting that first word in the sentence. And then we're going to want to look it up. We're going to want to see, we're going to want to have an iterator. So let's see. The verb grammar, the grammar that goes with this verb, is we're going to find that verb. We're going to do standard map.find. And that returns an iterator. So we're going to copy it by value, not by reference. So we're all good there. First, we want to account for the case. What happens if I typed in, a gobbledygook word? That's not in the list of actions. So if verb grammar equals actions.end, then I didn't recognize it. So we can write that back to the user. We can say parser error. Let's quote the word. Verb was not a recognized verb. Or is not a recognized verb. Okay, and then we'll put a new line in. So we're going to put a new line in. We also need to get server text from the last part. Okay, otherwise we have an iterator, so we're going to act. We're going to say, take that iterator. Now iterators of a map return a pair, a key value pair. So we want the second part of that pair. We want the value, and we're going to do .act. And let's give it the response so it can also talk back to the user. Okay, so this is the core of what our grammar system is going to look like. Is we're going to take the tokenizer. We're going to get the words out of the line. We're going to try to find candidate verbs or candidate grammar actions that correspond to the tokens we put in. And in this case, we're just looking up by the first word. And then if we found something, we're gonna run it. We're gonna act on it. And that's the way our grammar system is gonna work. So what does grammar line need, or grammar action need to look like? So grammar action HPP. Namespace mud. Namespace grammar. Class grammar action. Okay. So we said we're going to have some sort of act function that reports back to an OStream. And this is also going to be const. Okay. So we're in a little bit of a situation here, which is that if we look at the header for grammar, every verb is actually going to point to the same class. It's going to point to this grammar action class. And we could have maybe some sort of really complicated branching if then, if the verb was hello, then say hello back. If the verb was close, then disconnect. Else if. We're not going to do that. C++ provides a much better answer to that problem using polymorphism, and we're going to do that in the next part. But for now, I just want to get what we have so far to compile, so we can show the skeleton of our grammar system, and we are going to have every action be exactly the same. So we're just going to say, let's see, response. I successfully, or verb successfully recognized. So it was in the list. Recognized. Okay, yeah, let's put a little exclamation mark there just because we're so happy about it. And a new line. Okay, this ought to work. Let's see, and we've got our constructor there. Okay, so we need to populate our constructor. So we need to do our list of verbs, right? So let's just start with, let's say, we're going to say hello is the one we're going to start with. We're just going to say it's a grammar action. We're just going to use the default constructor that the compiler provides by default. All right, and let's edit our CMake list and see if this compiles. So let's see. Grammar.cpp. Okay, yep, headers. Can't forget about headers. So we need map, and we're probably also going to need string. Element, OP, QRS. Yes, I know the alphabet. Okay, and we got a little bit of a mismatch here. Why is that? Because we didn't put const. All right, so built. Let's see what it did. So what do we expect it to do? What do we expect what we did so far to do? It's reading the first word of our sentence, and it's looking up a grammar action. So it basically it wants to see if the word is in the dictionary. The first word is in the dictionary, and the only word we added was hello. So if I type something else, if I say, blurf, okay, good, we got that parser error. Blurf is not a recognized verb. Same thing if I say blurf the orc. Say blurf is not a recognized verb. Great. Now the one verb we did recognize was hello, and we wrote a response to that. We said verb successfully recognized. So even if I put some other stuff here, hello 2, 3, 4, it's going to say verb successfully recognized. So that's a good start. This is a good place to build off of. We're going to do some, in the next part, we're going to add the ability to have different actions based on what verb you put in. So we're going to talk about polymorphism. And then eventually we're going to build on this to also be able to recognize the other words in the sentence so that it can understand, for example, what you're targeting. Maybe even have different actions based on the syntax of your verb. So if I say, I don't know, pick up the box or pick the box up, well, that's the same action, but being able to recognize those different kinds of syntax. So that's what I'm going for. We've got a starting point. Let's look over our code again real quick. So our grammar system, it's just an object that you call parse on. You pass it your tokenizer so the grammar can get the words, and then it feeds you back out the response. It writes to the response. And how it does that is it gets the first word off the tokenizer, it gets the verb, it tries to look it up. If it doesn't find it, it complains. And if it does find it, it runs the action. Great. Okay. My name is Ken. This was Let's Code a Mud in C++, Part 14. I look forward to seeing you again.